derive the time complexity of the given algorithm. This is an algorithm to sort array in ascending order. Okay, let us assume our array A is this one with some 1, 2, 3, 4 elements, 20, minus 2, 60 and minus 30, and our n equal to 1, 2, 3, 4. Okay, there are 4 elements. Let us trace this first. When I equal to 1, I start from 1 to n minus 1. Remember, this is an iterative algorithm. Algorithms are two types, iterative and recursive. We analyze the iterative algorithms by finding the number of times each statement executes. Then we assume a cost and we will find the total cost of execution. Let us trace the algorithm first. When I equal to 1, j is equal to 2. Okay, it is I plus 1. Okay, then it will compare A1 and A2, that is 20 and 2. See this 20, that is AI. AI is 20. AI is equal to 20. AJ is equal to minus 2. They will swap. So you are getting the array minus 2, 20, 60, minus 30. This is the new array. Then J will become next value, that is 3. At that time, I will not change. The algorithm compares A and AJ. AI is, this is the new array, so is minus 2 greater than minus 2, AI greater than AJ. J is 3. In this, the third element is 60. Okay, it will not swap, no swapping. Then J will take next value, J equal to 4. Again it will compare, still I is 1, minus 2 against minus 30. Yes, this is correct. It will be swapped. So minus 30 will come here, minus 2 goes here, and 20, 60. This will be the new array. Okay, J is over I plus 1 to En. J is over. I will take the next value, I is equal to 2. Then it will compare A of I, that is A of 2, that is 20, is greater than A of J. J will take the first value, it is I plus 1, it is 3. That is third element, that is 60. This is wrong, no swapping. J will take its next value, again 20 greater than the fourth element, it is minus 2. It is correct. Those two elements will be swapped. Then minus 30, then minus 2, and this 20 goes here, and 60. This will be a new arrangement of the elements in the array. I goes for 3, the last value, n minus 1. Okay, that time J is equal to 4, I plus 1. It will compare A of I, that is the third element, this is the third element, 60 against A4, that is 20. this is correct. The array, it will be, these elements will be swapped. So minus 30, minus 2, and 20 here, 60 here. Okay. I have taken its last value. So this loop is over. The array is sorted. Sorted in ascending order. Okay. The algorithm works. Next is how many times each statement work. That is the next thing. For I equal to 1 to n minus 1. Okay. This will work. This will work. 1 to n minus 1, we have n minus 1 times, this is number of execution, then the cost per execution, then is cost of execution. Let us assume its cost is C1. Okay, so the cost of execution will be n minus 1 times this will be executed. So it is n minus 1 C1, and this one I plus 1 to en. We have seen that for every value of I, it works sigma I equal to 1 to n minus 1. When I equal to 1, j is equal to 2, 3, 4. That is n minus 1 times. Okay, when I equal to 2, j varies from 3, 4, isn't it? That means 4 minus 2 times. We can write it 4 minus 2. This is 4 minus 1. When I equal to 3, it works. J is equal to 4 only once. It is 4 minus 3. Okay, in general we can write it is n minus I, sigma n minus I. Okay, let the cost is C2, cost per execution is C2. So it will execute C2 into sigma I equal to 1 to n minus 1 n minus I times. Okay, this conversion happens for I equal to sigma equal to 1 to n minus 1 n minus 1 times. This cost is C3. Cost of execution is C3 into sigma I equal to 1 I equal to n minus 1 n minus I. Suppose this also works. The maximum times. So it will be sigma equal to 1 to n minus 1 n minus I. Okay, this also n minus I. Its cost is C4. This is cost per execution. So total execution cost is I equal to 1 to n minus 1 n minus I. To find the total cost of execution, we have to sum up all these values. So our Tn, time to process n elements, or time of execution when the problem size is n, it will be C1 into n minus 1 plus C2 into sigma I equal to 1 to n minus 1 n minus I plus C3 into sigma I equal to 1 to n minus 1 n minus I plus C4 into sigma I equal to 1 to n minus 1 n minus I. We have T of n equal to C1 into n minus 1 plus C2 into C2 into sigma I equal to 1 to n minus 1 n minus I plus C3 into sigma I equal to 1 to n minus 1 n minus I plus C4 into sigma I equal to 1 to n minus 1 n minus I. Okay. Then our question is, what is sigma I equal to 1 to sigma equal to 1 to n minus 1 n minus I. This is the question. Okay, when I equal to 1, it is n minus 1 plus it is sigma. When I equal to 2, it is n minus 2 n minus 3 plus when I take the last value n minus 1 it will be n minus 1. Okay, it will be n minus n plus 1. So this is 1. We know n plus n minus 1 plus n minus 2 plus up to 1, that is 1 plus 2 plus 3 plus up to n is equal to n into n plus 1 by 2. Okay, here this n is missing, it is up to n minus 1. So this will be up to n minus 1, it will be minus this is n square plus n divided by 2 minus n is equal to n square plus n minus 2n divided by 2, and this is equal to n square minus 2n and n here, so minus n divided by 2, and this can be written as if you take n outside, okay, it will be equal to n square by 2 minus n by 2. So this will be so our Tn will be C1 into n minus 1 plus C2 into n square by 2 minus n by 2 plus C3 into n square by 2 minus n by 2 plus C4 into n square by 2 minus n by 2. Okay, let us take this n square by 2 minus n by 2 common. So it will be c1 into n minus 1 plus n square by 2 minus n by 2 into c2 plus c3 plus c4. Okay, let us write it as c1n minus c1 plus n square by 2 minus n by 2 into some c5, and this will be equal to c1n plus n square by 2 c5 minus n by 2 c5 minus c1. If you take n common from this one and this one, you will get n into c1 minus c5 by 2 plus n square by 2 c5 plus minus c1. We can write c1 minus c5 by 2. c5 is a constant, c1 is a constant, c5 by 2 is another constant, so it will be c1 minus some constant. We can write our t of n equal to n into c6 plus n square by 2 c5 minus c1, and this term will be the dominating term. So the complexity will be big O n square.